Hi, Mrs. Hassler here. We're going to go through the 2.4 notes together on solving equations and inequalities. But today we're adding another layer of combining like terms and using the distributive property. Okay? So let's just review combining like terms, or CLT. And combining like terms means that we are going to add or subtract all terms with common parts. Now, this should be a review from previous years in math, so we're just going to go through and remind ourselves of what that means. In part A, I have 4x minus 10 plus 12 minus 7x. And I like to use different colored highlighters or pens to organize the items that are like terms. So the first term I look at is 4x. To be a like term, I have to match up with another term that has the same exact variable. So the other term that has the same exact variable is this minus 7x. Notice that I'm using the sign that's in front of that term. That sign in front of the 7x tells me how I'm going to combine these like terms. I'm going to combine these like terms by subtracting. I'm going to say 4x minus 7x gives me a negative 3x. Now maybe you don't have highlighters or you're using colored pens, so you could always circle or underline common terms as well. I have negative 10 plus 12. Those are constants because they do not have variables. So negative 10 plus 12, when I add those together, I get a plus 2. And then I just want to double check that my remaining expression has no more like terms. The first term has an x, the second term's a constant, so I've completely simplified this expression. All right, let's do B. So again, in B, I have a 2y, a plus 6y, a plus 1, that's not a like term, and a minus 11y. So I'm just circling all the terms that are alike. 2y plus 6y is 8y. 8y minus 11y is a negative 3y. Now, I only have a single constant. There's nothing to combine the plus 1 with, so I just rewrite it, plus 1. And again, my expression is completely simplified. I have a term with a variable. I have a constant. I cannot put those two things together because they are not like terms. All right, so the second layer we're adding today is the distributive property. And the distributive property is just multiplication, okay? So distributive property means that I'm going to multiply the term on the outside of the parentheses and just for space, I'm going to just make the parentheses symbol, okay? So I'm going to multiply the term outside of the parentheses by each term inside the parentheses. So when you did this in your past math life, it's likely that you talked about drawing arches or arrows or making rainbows or had some sort of saying to help you remember what to do. I personally like to draw the arrows to get myself started. So if we follow these directions, we're going to multiply the term outside of the parentheses. In this first example, that's a 2. And we're going to multiply it by each term inside the parentheses. So I'm going to draw arrows to keep track of what I've done. I have to multiply 2 times the 3x. Well, 2 times 3 is 6, and I'm going to keep that x variable with my term. I then have to go back and multiply 2 times the second term. And that second term is going to be negative 7. So again, this whole theme of keeping whatever sign is in front of the number and using that sign and the number throughout our process. So 2 times negative 7 gives me a negative 14. So when I distribute that 2, I get 6x minus 14. They are not like terms, so I have simplified completely. All right, let's take a look at B. So in B, I have 3 minus 4 times the group or quantity, x minus 20. Order of operations says that I should multiply before I subtract. So I do not want to do 3 minus 4 to start. That was subtraction. I want to distribute or multiply the number outside of the parentheses to each term inside the parentheses. Okay, so based on order of operations, I have to do this distributive property or multiplication first. And notice again, I circled the number and sign in front that is being distributed. So I'm going to distribute negative 4 to 1x. Technically, if there's not a number in front of the x, there's a 1 there, okay? Negative 4 times 1x is negative 4x. Negative 4 times negative 20, right? Keep the sign in front of the number. Negative times negative is positive, 80. And then don't forget that you have to bring down that 3 that is in the original problem. And now I can look to see, do I have any terms that I could combine? Yes, I do. Okay. I have a 3 and a plus 80 that can be combined. So when I combine those, I get 83. And then I'm just going to rewrite my minus 4x. Okay. All right, so now let's add these layers to our equation solving. So I'm going to do a couple problems with you. And then your job is going to be to go finish the rest of these problems and turn this document into Google Classroom. Okay, so solve the equation or inequality and graph your solution. Show your steps. The first thing I like to do personally is I like to draw in a dividing line at my inequality symbol to remind me that I'm working with 2 different sides of that inequality symbol. Okay, I like to look at both sides of that inequality symbol to see if I have any terms to combine that are like terms, or if I have any distributive property to take care of before I start doing inverse operations. So on this left side, I do have like terms that I could combine. Negative 9 plus 15 is 6. I'm going to rewrite my inequality symbol. On the other side, the right side, I also have like terms that I could combine. I have a negative 3x and a plus 5x. And when I'm working on one side of the inequality symbol, I'm going to complete the operations exactly the way I see them. Okay? So if I'm just working on one side of the inequality or equal symbol, I use the exact operations I see. Negative 3x plus 5x combines to give me a positive 2x. Now I have a 2-step equation or inequality like what we've been working on. Now is when I use opposite operations or inverse operations, okay? When I'm working on both sides of that inequality symbol, I use my inverse operations to get rid of terms. Okay, so I want to undo this addition, so I'm going to subtract 12 on both sides. 6 minus 12 is negative 6, less than 2x. I have 2 times x, so I'm going to use the inverse operation, division, and I'm going to divide both sides by 2. I'm dividing by a positive number, so when I do this division, I'm going to keep the sign as is, okay? And 2 divided by 2 gives me 1x. So my final answer is that negative 3 is less than x. Or if you don't like your variable written on that side of the inequality symbol, we've talked about the fact that this is equivalent to x being greater than negative 3. Same, means the same thing, okay? So I want to graph this. I'm going to get 3 numbers on my number line, my answer in the middle, a number that's smaller than -3, a number that's bigger than -3. Because this is the less than symbol, there's no equal to bar, I'm going to have an open circle at -3. And this is -3 is smaller than all the other numbers, okay? -3 is smaller than -2, than -1, etc. So -3 is less than all the other numbers, then my solution is going to be all the numbers bigger than -3, which is really what this expression says. All of the numbers are greater than -3, okay? All right, let's do one more example together. So example number 4, I have -13 minus the group x plus 6 greater than or equal to -8. So again, I like to get my bar running down my line underneath that inequality symbol. Helps me keep track of what I'm doing on each side of that bar. I look for combining like terms or distributive property before I start considering inverse operations. I do have a group of parentheses, and there's no number in front, which means technically that number is a 1. Again, like I said earlier, we have to do multiplication or the distributive property before I can subtract the -13 with the -1. Okay, so I'm going to circle that I have to distribute first, and the number I'm distributing is -1. -1 times x is -x. -1 times +6 is a -6. I'm going to rewrite that -13, my greater than or equal to symbol, my -8. Okay? So I distributed. I'm going to check for combining like terms. On the left side, I do have like terms that can be combined. And so again, they're on one side of that inequality symbol, so I'm going to use the operations I see. -13 minus 6 is -19. I have this minus x greater than or equal to -8. Now I'm down to my two-step inequality, and so I can use my inverse operations. I'm going to add 19 to both sides to undo that -19. Remember, I have to bring down all of this, -x, greater than or equal to 11. Technically, there is a 1 in front of this x, a -1, and I have to finish solving by having a positive x as my final answer. And so I'm going to undo this multiplication by dividing both sides by -1. And because I'm dividing by a -1, I must flip that inequality symbol, okay? And so negative divided by negative is a positive x. Because I divided by a negative, I must flip my inequality symbol. 11 divided by -1 is -11. So this is going to be my final answer. I need to graph this. So 3 numbers on my number line, -11 in the middle, a number smaller than -11 to the left, a number larger than -11 to the right. Okay, I have a less than or equal to symbol, which means I'm going to have a closed point at -11. It says x, all numbers are less than or equal to -11. So all the numbers that are smaller than -11 are to the left of -11. Okay, so your job is going to be to complete 5, 6, 7, and 8 and upload that to Google Classroom. And as always, if you have any questions, feel free to email your teacher and let them know that you have questions. All right, have a good day.